So the next topic is the losses and the efficiency of DC machines. The losses and the efficiency of DC machine. So the first one, why we have to determine the efficiency? Why we have to determine the efficiency? To get the different outputs. Whereas anything, why we have to determine the efficiency of DC machine? Whether it's here, generator, or it may be a DC motor. To go for any machine, it doesn't give 100% efficiency. Why it doesn't give efficiency? What the difference? Anyone? There are some losses. Okay. So because of that losses, the efficiency gets reduced or increased. Reduced. So the input is given, the output will be less than the input. The output will be less than the output. Okay. So may know what are the different types of losses in the DC machine? The iron loss, or it may be called as magnetic loss, friction loss. So these are the friction losses, and along with linear losses. This is called mechanical loss. Okay. So these are the various losses in the DC machine. So this is called a copper loss. This is called as mechanical loss. Mechanical loss is consist of friction and immediate loss. So what is copper loss? Copper loss is nothing but heat loss. It is nothing but heat. How the heat will be produced inside the machine? The current is raised. How the heat will be produced there? I square R is different. Okay. How the winding is converted? How the winding is act as heat? How the heat is produced in the winding? Which phenomena it will involve to produce the heat? The flow of current in the coil. How it produces heat? So the coil, the winding, it is a combination of resistance and the reactance. So the reactance which is used to produce the flux, and the resistance, it opposes the flow of current. When opposing the flow of current, the heat will be produced. Okay, so the winding is made up of copper. So that's why it is called the copper loss. Winding it produces an heat because of a copper winding, so it is called the copper loss. Okay, so the copper loss is nothing but whether it's a variable or constant. It is a variable loss. Why it is variable? Depending on the current, it is based on the load. If the load is varies, the currents are changing. The current is changing, automatically the copper loss gets changing. Okay. So what is that average percentage of copper loss in the machine? 15 to 80%. So in a machine, around 15 to 80% of in a total losses. In a total loss, out of total losses, 15 to 80% of losses which is produced by the copper winding. This is produced by the copper winding. Okay. So what is core loss? Magnetic flux current area and core loss. What is core loss? It is dependent on the reversal of magnetic flux. Okay, reversal of magnetic flux. That is what we started investigating in core loss. Hysteresis loss. So the hysteresis loss is nothing but it is the what is that? The reversal of flux. The frequency of reversal of flux, because at the time it will be a north south pole, so the polarity is always getting changing. Polarity always getting changing during the cycle. So when reversing the polarity, the flux is also getting reversal. Reflector is also getting reversal, forward reverse, forward reverse. So reflector is getting reversal. So during this reversal, some amount of flux gets lost. So the block is called hysteresis loss. Okay. How we can minimize the hysteresis loss? How we can minimize the hysteresis loss? By selecting the core material. Okay, so that is something like hysteresis. If you are choose some material, it has less hysteresis coefficient. Less hysteresis coefficient. That's weighing is better for silicon free. Weighing is better for silicon free. So like that, if you are choosing different combination, that is such a lot. So that we can able to minimize the hysteresis coefficient. So the hysteresis losses can be minimized. Okay. And laminating the core. By laminating the core. Okay. So if you are laminating the core properly, the eddy current losses can be minimized. The eddy current losses can be minimized. So the core loss it consists of two losses. One is hysteresis and another one is eddy current. So the hysteresis losses can be reduced by selecting the proper core, and eddy current loss can be replaced by proper lamination. So hysteresis losses are nothing but the conductor fraction and the EMF will be reduced because of the reduced EMF. There will be an reduced current in the core. There will be a reduced current in the core because of the eddy current. It reduces some loss. Okay, and the third one, mechanical losses. So what is friction losses? What is friction and windage losses? It is against the wind. So, if the motor is rotating in a particular direction, in the same direction, that is the opposite direction, there will be some wind velocity here. So, the wind velocity opposes the movement. So, it opposes the movement. So, there will be a relative amount of losses will be there. That is called windage. And what about friction loss? What about friction loss? What is friction? Question. So initially, we have to break this friction in order to rotate. So these are the various laws of the DC machine. So out of these laws, the upper law is nothing but a variable law. It is mainly dependent on the load. The load is integers, the upper law will be integers. And whatever the core and the iron losses, it will be constant. It is fixed. Mechanical law is called spray law. It is called spray law. So I think the law is separate just in the DC machine. So that only we can able to determine